Hail also my tribe, and welcome to the Modern Barbarian Podcast. I want to start this week by apologizing for missing last week's episode. I was out of town for a Marine Corps League convention and then wound up getting sick on top of it. So last weekend turned into a bit of a shit show. But I'm back this week and I've got us another really fun topic to discuss for modern homesteading, being a modern barbarian, and it's something I bet that you haven't thought of. A thing that I bet you may not be using in the best way possible, especially in today's climate and environment, right? What am I talking about here? Well, let's start in and let's find out. What if I told you that I had a magic machine that with just a little bit of time investment to learn to use it can make any piece or part you need for any repair project you may be working on? Not only that, but really anything you decide you need, this machine can make appear in just a few hours. Literally anything your heart desires. If it fits inside the box on the machine, it can produce. Would you say that it was too good to be true? The truth is, this is technology and not magic. This technology has existed for a while, but most people just have not seen the value of it yet. What technology is it? 3D printing. Most people see this as a machine that costs too much money and makes trinkets. This is a gross understatement of the capabilities of 3D printing. The possibilities for the small homestead are endless. You can make everything from custom tools to garden markers. Need a specialty gasket for a piece of equipment that the shop either doesn't have in stock or that shop has gone out of business for some strange reason? You can print one. Need a specialty tool holder for your pegboard? You can print one. Need a special tool for maintaining your chainsaw bar? Starting to see where I'm going with this? The equipment and programs needed for 3D printing, right? Well, sorry, let me back up there. I like to talk to you guys a little bit after I do the intro read before I just jump right off into it. So, why am I so excited about 3D printing, right? Why do I think that this is such a great technology? Well, literally anything that fits in the box on the printer and can be made out of a meltable plastic, this particular machine can make. Now, there's several different types of 3D printers, and we'll get into that a little bit later, what types there are. But think about it. I mean, literally anything. It can print very small, thin things like gaskets. It can print large things like tools or, what's the word I'm trying to say? Wow, brain just went completely retarded there. Anyway, you can print things for like markup tools, like for laying out templates. There we go. Way to go, brain. Thinking is hard sometimes. Anyway, you can make templates for drilling out holes and laying things out together. You can make custom small little tools. Like I've got one that I printed for when I go backpacking that holds all of my cordage and a lighter and holds a little blade in it for cutting the cordage, right? So there's all kinds of these neat things that you can do with this that only your imagination is what limits you. Uh, Now, the reason I think this is so great for a modern homestead, for a survivalist type mindset, is this gives you a means to manufacture things that you may not be able to manufacture any other way. Um, Small parts for equipment. A lot of it can be made with a 3D printer. It won't be as good, right? But it's better than nothing. And in some ways, you can make it even better. It's all about your understanding of the equipment and the parts and how to use them and how to use the machine. Uh, if you need parts to fix, like let's say a dishwasher that you've got using, and for some reason spare parts are no longer available, you can just go make a new bracket for your dishwasher to put it back together so that it works again. You can just make, uh, switch holders for cars and vehicles to put them together. You can make custom bracketry to do all kinds of stuff, right? So it's just, again, it's just such a useful tool to have once you spend some time with it and start to understand its capabilities and limitations. So let's jump off into a little bit about 3D printing. And I think as we talk about it more, you'll learn more and more about it and start to see more and more the capabilities of what it can do for you. Now, I will say this, there is some learning curve here. So we'll go over that too. You know, 3D printers, especially the early ones, they were difficult to get to work sometimes. Now, the new ones that are out now, you could literally buy a machine, buy the filament for it, and hit print, and it goes. Right? It's super easy. And there are places online to like download stuff, so you don't even have to know how to do the 3D drafting to make it. But I think you should learn that too. So we'll talk about it. So there's some equipment that you're going to need for doing this 3D printing thing. First one's obviously going to be a computer. You need a computer that's capable of handling 3D drafting software, the slicing software, all the stuff that the 3D printer needs. Then you're going to need the 3D printer itself. So those two, you kind of want to make sure that they work together. It's not super difficult to do that. Most 3D printers will run off of USB or Wi-Fi. Either one, depending on what your setup is and what you like. I prefer USB. I think it's just easier than trying to keep stuff set up over Wi-Fi. And I set a dedicated spot for the printer, so I just plug it in. Right. So make sure the computer that you're using has a few things. One, you're going to need the capability to do three-dimensional drafting. So you need a computer that has enough capability inside of it to do that. You know, graphics cards, memory, those type of things. You can look that up for each of the programs that you look into. And there's several different ones. Some of them even run on the internet and are, very, very easy to use, assuming you believe that the internet will always be there. But just make sure the computer that you've got can do it. I'm running on this old Lenovo machine that used to be my wife's. I bought it specifically for her to do drafting with, so that wasn't a big deal. And it works perfect for it. But I mean, this is like a 10-year-old or more computer, and it still does everything we need for this. So you don't have to go crazy. You could buy this computer used probably very cheaply now, and it does everything we need it to do as far as that goes. Then again, the 3D printer. Now, I have experience with several different 3D printers, and I will talk to you about the few that I have experience with. My first 3D printer I bought myself was made by XYZ Printing, and it was a Da Vinci printer. And so the cool thing about the XYZ system is that it was the first one to use what they call smart filaments. So the plastic that these things print in come on a spool, and it had a little chip in it that when you put that spool on your printer, it knew exactly what filament that was and what settings it needed to be set on to print in that filament. So you didn't have to learn as much about, well, these filaments print at this temperature and this speed and this way. That machine knew how to work with each individual filament, and it had the thing on it, and you just went. The downside to that is that you have to use that brand filament. And so there's no way around it. You have to buy it with that one. So upgrading later, this one is the one I get to use at work a lot because I've saved us, it's crazy what you can do with these, and I get to do it at work now because of some of the stuff I've done for them. But regardless, we wound up with the Ultimaker S5 at work with the full material station, air handler, all the stuff, all the bells and whistles. Now, this is about a $10,000 printer. First one we were talking about was like a $300 printer. Now this $10,000 printer has basically a cubic foot print box, so it can print almost a foot in every direction. That can make huge parts, right? Massive things if you need it to. And we've done a bunch of that. But it's a very precise printer. It has proper material storage on it. And you can make an amazing amount of things on a printer that size. It has capabilities that the smaller printer doesn't have. It runs dual print heads, which means you can use a support filament, or you can print in two types of filaments at once, or two colors of filaments at once as you're messing with it and learning it. The water-soluble support filament, though, is one of the coolest things that I've come across with that you can do with a dual print core head. We'll get into that in the post-processing tools about how that works, but just know that that's a thing you can do with it, and it's really cool. So that S5 has made thousands and thousands and thousands of parts for the company that I work for. Occasionally I get to do some small things on it for myself as I'm learning new techniques or trying things out or doing test prints after I have to do repairs on it and such. But those are the two printers that I know, and I would highly recommend an Ultimaker if you're going to get into the market for one for yourself. They are an excellent tool. If you need a cheaper one, there's lots of cheaper ones available now. They've become really, really popular. I've heard really great things about some of them, MakerBots and all those things. And even some of the cheaper ones on like Amazon you get for a couple $100. But I think it's worth having one and learning to use it in case you need it. Next thing you're going to need are some post-processing tools. Now what that means is this thing, it prints it, right? A piece of plastic or whatever it is comes out. But sometimes you need a few tools for dealing with this to turn it into what you actually want. There are supports that are needed in certain prints. And with a single print head, you're going to use the same material for the support as you are for the print. So you'll need a tool to cut that support off, clean it all out. If you're using a dual print head, like I talked about with the S5, you can do something called a water-soluble support. This is called PVA, right? I don't remember what that stands for, but it doesn't matter. It's a water-soluble plastic that can be printed out of the 3D printer, and it's used for the support to hold the structures together while they print. And then you take your tool out of the print, or your piece out of the printer, and you drop it into water, and the stuff just dissolves. Now, post-processing tools, they make a special tool just for removing that filament. Not crazy expensive. It was a couple $100. You drop this thing in here. It keeps the water stirring and agitated and all the stuff. And it's got a special basket for holding it. It's a really nice tool. And again, Ultimaker makes it. And it does a very good job of removing all of the water-soluble supports off of whatever it is that you've printed. Now, you can do this yourself if you want, easily with just a 5-gallon bucket and some kind of way to agitate the water. You don't even have to agitate the water. It will dissolve on its own. Or you can go down there and mix it and agitate it. But what I found is usually the cheap way with just a bucket of water takes roughly 24 hours to get everything to dissolve out and, have a clean part. Whereas the machine that Ultimaker makes with the continuous movement and the way that it works takes about 2 to 3 hours. So it's roughly 10 times faster. Now, you can make your own machine, right? Again, it's just agitated water. So if you can keep it agitated and not have to do it yourself, 2 or 3 hours. But post-processing tools, little snips, picks, some way to handle the water, some way to clean these things up. You're also going to need the software. And there are 2 types of software that you'll need. One is a 3D drafting software. So this is the software you use to draw your parts, to design them, make them, and output a digital 3D model that you can then use to make the print from. Now, my personal preference here is a program called Fusion 360. They have a free trial on it to buy it after that for personal use, so that I think it's not super expensive anymore. Let's take a look. I think you guys would appreciate knowing this, so we will just go look it up. The joys of having a computer here. So, go look at, it's an Autodesk program, and this is an extremely powerful program. So, right now there's a free trial. Wow, prices have gone up. It is now $382 a year to have this program. That's crazy. It was nowhere near that expensive when I started. But either way, it's a good program. It's a very good program, and drafting is not a cheap thing. And there is a free trial. So I don't know how long that free trial lasts. Let's see. If we click the free trial button and see if it will tell us. There's an Autodesk Fusion for personal use. Let's see, a free 30-day trial for professional users. For educational use, you can use it for free for students and educators. Only for educational purposes. For-profit use requires a paid subscription plan. And then there's also for personal use. Personal use is a limited, free version that includes basic functionality for home-based, non-commercial projects. Hey, there you go. So your home version for non-commercial, for personal use, there's another free version. So this is absolutely free for home use. And yeah, it'll be a little bit limited. Some of the really high-end tools that you're not going to need may not be there. But this is a free, and this is really, really good software that would be expensive to buy. So I recommend still Fusion 360, now that I know that it has the free personal use license. There's also some online software, things called, I believe it's called Tinkercad. Let's go double check that though. Yep, Tinkercad is the online software, another completely free one. And this one works a little bit differently. Tinkercad is like a shape-based. So you draw in little like squares and circles and triangles, and you add and subtract. You can make everything with this. I've done a bunch of stuff with Tinkercad when I first started 3D printing, and if you're new to it, it's a very simple, kind of intuitive way to learn some three-dimensional stuff, and we'll get you there. However, again, I would recommend the Fusion 360, but Tinkercad is another Autodesk program, and it's also completely free. So there's a few routes there for you to mess with for completely free stuff to be able to do the 3D drafting. I recommend learning Fusion 360. There are a great number of videos online on YouTube and stuff about how to use either one of those programs. The Fusion 360 downloads to your computer, and it can be used offline with no internet access, so that's part of the reason I recommend it. Also, just because of the amount of people showing you how to do everything with it and how intuitive it is once you've learned it, you can literally make anything in that program. The next program you're going to need is called a slicer. Now, this is going to sound weird, but 3D printers print in layers, right? So in order to take, say, here, those of you on camera can see, if I wanted to print an object that looked like this remote, it's going to print it in little tiny layers that are, less than a millimeter thick. And what a slicer does is it looks at this object that you have in digital form, and then it's going to cut it into a series of layers and tell the printer where to lay that plastic in each layer to build this up in tiny, thin little layers. So your slicer program is very important. It is what communicates between your 3D drafting, your model, all this time you spent to create something, and the printer. The better your slicer program is, the better your product will come out. I personally like the one made by Ultimaker. It's called Cura, Cura. It works very, very well, has very good outputs, and is designed to be universal. So it will output in a format that any 3D printer can read. If you use the Ultimaker 3D printers, it's even better. They direct connect, it talks, it's designed for it, but it will work with any 3D printer. There are other slicers out there, several available for free online. Cura is free also. So just find one that you like and work with it and learn it and know how to use it. The DaVinci printer that I have here at the house came with its own software, and it works. It also came with some basic 3D drafting software, very, very primitive, but it does work. So there's that. So that's the last piece of software that you need. Also, I'd recommend learning about a website called Thingiverse. Thingiverse is a 3D model sharing platform online. So you can go online, you can find models and of parts that other people have designed. Gears and hammers, tools. They have firearm stuff on there, everything you can think of. And you can just go and download it and have something to try and mess with your 3D printer. Go find something usable instead of scrap to be messing with. Don't print tiny tugboats for trials when you can be printing something useful, right? So mess around with that. Also, it gives you access to designs that thousands of other people, millions of other people, have already put all the time into and decided to share. So you can just go on there and do some searching, find parts and pieces and stuff that already exists, and literally download it and hit print. The other thing too that I like about this is it gives you the ability to stockpile things that digitally that you may need for a future scenario, right? So instead of having to draft and design every one of these individual parts yourself, some may already exist. And you can just download it, save it to a flash drive or a hard drive or your computer or whatever, and have this digital library of things that you may need that at any point you just hit the print button and it comes out on the 3D printer. So it turns this digital space stuff into something in the real world that you can use. So Thingiverse is great to have just because of the sheer volume of things that are on there, the ideas you can get from it, and the cool things that you can get that saves you a lot of time. So now we've talked about what equipment and things go into it. Let's talk about the basic steps of 3D printing. How I go from my idea to this exists, right? So there's a few basic steps. You're going to want to start by figuring out what you need, right? So again, let's look at this little remote here. If I needed a new case or a new battery cover for this remote, right? This piece right here comes off, is lost, and I decide I don't want to buy one. I want to make my own little battery cover for this remote. This is something that a 3D printer can definitely do. So we're going to start by either going to Thingiverse and finding this, or we're going to draft it ourselves, right? So let's just do the experiment here. If we go to Thingiverse and see if a Roku remote battery cover already exists on there. Do a search, Roku remote battery cover. Okay. Yep, Roku remote battery cover already exists right here, and it's even the Roku Ultra that I have here. There is a battery cover right here for this on Thingiverse already. So it's literally as easy as hit that, hit the download button, and I would already have the model. If I needed to model this myself, I would go into Fusion 360, I would take a pair of calipers and start taking measurements and laying this all out, right? Draw a rectangle, take the edges off of it, or I'd look at it headlong like this and draw that and then come in. There's several different ways to model these skins. But I would get into my 3D drafting software with some calipers and start measuring it. But since it already exists, somebody did all that work for us and we know which one we need, we could skip ahead and just have that model already ready. So that's step one, drafting or finding online the part that you need, right? Now, just a quick aside, right? We found something like a remote cover just because it was sitting here. But let's see, just for my curiosity, if they have, let's say, a carburetor gasket for a steel chainsaw. Do a quick search on Thingiverse. Nope. Nothing there for that. So we would have to do that ourselves. No, but there are some gaskets on here, it looks like. Let's see. Nothing good. Alright. But anyway, the remote is there. So, and you could draw that yourself if you needed to have the carburetor gasket. So it's done step 1. Draft or find the part you need. Step 2, you're going to import a 3D file into the slicer. So, if you are drafting this yourself, Fusion 360 has several different outputs, but the one specifically designed for 3D printing and modeling is called a 3MF file. So you'll start with your draft and output or export a 3MF file of your design, and that gives you the file to import into your slicer. If you're downloading it on Thingiverse, it's probably going to be an STL file, which is the file extension type .stl. Either one works, but you get that file and you import it into your slicer. So the slicer is, for me is Cura. So I open the slicer and I go to open and I find the file for the thing I want to print and I import that into Cura, the slicer. Then I position it. It has a picture of a print bed on it. You tell it what kind of printer you're using. And you position it on the print bed where you want it to print at. And then you start setting up all your settings, telling it what filament you want it to print in, because it sets up settings for the filament that it tells the printer to use. Tell it what filament you want, what percentage infill. So for a shell like this, you're just going to print it solid. But if I'm printing something much larger, it takes up a lot of plastic. Let's say I wanted to print something like this axe head here. These for those of you on video. For those of you just watching at home or listening to the podcast, I'm holding a small Viking axe. And if I wanted to print something this size, I would do it differently, right? I would do a shell that was then mostly hollow with some kind of support structure inside. And you can use Cura to pick that support structure. It will do hexagons, it will do triangles, it'll do all kinds of inlays for how dense of a support structure you want in it. And then you tell it how dense to make it. Anywhere between 0, which is just a hollow shell, and 100%, which is, a hard, all plastic piece. And that saves on how much filament you're using for certain stuff and cuts weight. So it all depends, like, how strong you need it to be and how light you need it to be. But you can experiment with that on your own. But that's step 2. Drag it into the slicer and go through all the stuff and set up all the settings for how you want it to print. And once you've prepared all of that for printing, you're going to hit the slice button. What that's going to do is take all your settings and all this stuff, and it's going to turn it into that series of layers that I told you about. And it creates something called a G code, which is what, machines like that, CNC machines, which is all it is. It's just a CNC machine, really. It's the code that they use to move around. So it tells it where to move the head, at what speed, at what temperature, how far up to move, and do it again, and all that series of stuff. And it would, if you laid this out here, you would trace out an outline and then start filling it in. And then go up a tiny amount and trace out an outline and start filling it in. Right? Until it can make all of what you've told it to make. And then that digital file is then exported into a flash drive or sent directly to a 3D printer. And that printer then reads that file and begins to build the part that you've requested. So it uploads it into it and it'll tell you, hey, you need to set this stuff up on the printer, put this filament in, get this stuff set up, whatever, and then hit the go button. 5 steps, right? That's all it takes is 5 steps. Draft it, export it from the drafter to import into the slicer, prepare for printing and slice, import it into the printer, and hit the go button. And in 5 steps, you can be making whatever it is you want to make. And with some of the printers out there, like, you don't even have to work on plastic anymore. They have laser printers out there that are extremely expensive, don't get me wrong, but they'll print in metal. It's called sintering. It uses a laser to bind the metal together and will print metal parts. There's resin printers if you want to make small stuff in very high detail. Does ultra thin layers of resin and hardens it and it will print resins. So a lot of people like that. And then for me, I use what they call FDM, or fused deposition modeling, which is printing layers of plastic that fuse together. So there's several different types of printing that you can get into, and they all make different stuff. So something to think about there. But really, it's just 5 steps, and you're off to the printers, right? Now, the possibilities with this technology are basically endless. You can make parts, tools, gaskets, etc. That's your most direct use. Things that you physically need, you just go make right out of the thing. You can print in a lot of different material types too, like nylon or PVC or different types of plastics, all that stuff. There's carbon fiber infused plastics to reinforce them. Then there's the metal printers and the resin printers and all that stuff like we talked about. So there's a vast array of materials that you can print in. But let's say you've just got a basic FDM, fused deposition plastic printer. And the part that you need needs to be silicone, like an RTV rubbery soft silicone. It's not going to print that. But what you can do is print a mold, right? So you take and you would, I don't have one here, but say we wanted to mold this axe head or a gasket or whatever. I would design this head in the 3D modeling software and then use it as a tool inside of that software to build a big box, lay it in it, and cut it out, right? And it would make a mold of this. I can then print that mold and fill that mold with the material that I want to make it out of. So I can use that to cast in resins, waxes, all that stuff by making molds with my 3D printer. And that's how you would make, your very complicated gaskets that need to be very soft, that you can't just print in a nylon or something like that and use. You could pour the resin into it or pour the silicone into it and let it set up into that gasket. Or you could do wax casting for something called investment casting. So if I wanted this actual metal axe head, I would still start with my 3D printer and I would make a mold of this head in the 3D printer. I'm then going to cast that in wax, use that wax with some casting sand to do something called investment casting, and then pour molten metal that I melt in a crucible into this into this cast made from sand with the wax inside of it. The wax will be burned off by the molten metal and leave me with this metal head inside of it. And then I've gone from 3D printing to a metal part. Now, there's some other stuff you need in order to do that, right? You're going to need a crucible, you're going to need the burners, you're going to need some practice and the casting sand and the wax and all that. But if you set this aside and you mess with it and you have some of that stuff there, in case of emergencies or just for fun, whatever, you can use your 3D printer to make things in metal that are good cast, hard steel, iron, bronze, whatever it is you need, parts. Another thing you can do with your 3D printer is replace most of a hardware store, right? Especially for some lighter duty things. Light switch covers, brackets, hinges, latches, door handles, drawer pulls, brackets for shelving, all that stuff. If you lose one of these little things out of one of these, you can make another one of those, right? You could print an entire organizer. All the kind of stuff you would go get at a hardware store for small projects, you can make on a 3D printer. It's probably more cost effective right now to go get them at a hardware store, but making them yourself lets you make it exactly to your specification, to exactly your thing. You don't have to get close enough. It also means you're making it yourself, which means you're not paying taxes on it because fuck the feds. But you're getting your experience and you're learning how to do it yourself so that when the time comes, yes, I can make one of those. Here, draft it up, boop, right? So it takes something mundane like a small repair that needs a bracket and turns it into a skill learning exercise for you, where you take your equipment and you draft it, you print it, and you fix it from A to Z. It was all you. Come out of your head, off of your machine, into the real world, and you fixed it. Self-sufficiency at its highest order there. And that's an amazing thing that you can do with this technology. So, why is this type of stuff important for a modern barbarian? Oh, excuse me. Sorry, I thought I was going to sneeze there. I just had a nose itch, I guess. But, either way, why is this important for a modern barbarian? If the store's closed, you will still have the ability to make parts, pieces, tools, etc. yourself. I know this relies on some technology, and that does make it a weakness. But in this scenario, I believe most likely it would be a help, right? I don't think in what's coming that we're all going to lose all electricity or there's going to be some big solar flare that blows your computer up, right? That's not the scenario that I personally believe we're headed into. I personally believe that we're headed into more of a civil war type scenario, especially with the shit that's going on in Texas right now and how gung-ho the liberals are to start killing people over it. And the country is basically split directly in half. Texas and 25 other states said, go fuck yourselves, we're not doing it, we're closing this down. And the feds are starting to put sanctions on their own country. So, yeah, it's starting to get pretty dicey. And if that's what happens, having a 3D printer at home when the supply and infrastructure is starting to get messed up makes a lot of sense to me, right? I can just print this stuff here. I don't have to get out and all crazy. I can make it whatever I need and be more self-sufficient. Which leads me to the next thing is why I think it's more important for a modern barbarian is that increased self-sufficiency, right? We learn to do it ourselves instead of counting on others. By starting with it now, before you have to have it, you can learn to use the technology while you still have time, right? You can use it for small projects, playful things, make toys for your kids, whatever, and you have it there. Which is something, that's something I didn't even think about. Toys sometimes are important, right? If you've got grandkids or young children or part of your tribe have children, there are going to be times that they want shit to play with, and you're going to need to take care of that need for children. Being able to make a cool toy off of your 3D printer, that's not a bad thing to be able to do. You take some time with your 3D printer and now kids get Christmas again, which might not would happen any other way. So something there to think about too, and increased self-sufficiency. Learning to do it yourself instead of counting on others. This is a technology that helps facilitate that. It also gives you trade fodder. So let's be honest, most people out there are not going to learn to do this. The few of you that listen to my podcast may start to understand it and may go buy a cheap one and play with it and try it out. But most people aren't, right? So if you're the person in your neighborhood when everything goes down that has this technology, now you can become the hardware store. You have the brackets, the latches, the gates, the hinges, all that stuff that they would use to go buy. You have the ability to make the custom parts to keep their chainsaws and weed eaters and all that shit running, right? To fix the cars, put new diaphragms in them. You can hit print and make a diaphragm for a carburetor come out of a 3D printer with the right resins. And they're not going to have that. So now you do, and now it becomes trade fodder, right? It will help not only your tribe, which you would do this for your tribe for free, right? But those outside of your tribe, but your immediate neighbors. You can't give everything away, but you could trade. Say, here, yes, I can make you the part to fix that, and you give me some canned beans or some fuel, or you come do some work for me, right? Now you're turning this tool that you've got in this really bad scenario into a way to help your community and to keep for the free market alive. Keep capitalism alive. Keep freedom alive. Trading and bartering is one of the best things that we can do in these types of scenarios to keep civility and humanity going, right? We need to take care of each other, but we need to do it in a way that everybody is fair and equal and everybody comes out happy. That's what barter is. I have this stuff that you need, you have this stuff that I need. I think they're worth each other. Here, let's trade them. Right? That is the most fair form of exchange that has ever existed. This gives you some extra stuff to throw into that exchange, that barter system that will come back in the days to come. So that's why I think this is an important tech, guys. I mean, think about it. At home manufacturing of complex parts that you wouldn't necessarily be able to make any other way. All for a couple $100 and a little bit of your time and being smart enough to stockpile some resins or some filaments for your 3D printer. Having a way to keep electricity to it. Even if you got to run the damn thing, like it'll run off of a little battery solar generator. It doesn't need a whole lot. So, there's something to think about. Something I bet most of the survivalists, the doomsayers, if you will, out there aren't talking about, right? Think like a modern barbarian. Think outside the box. Find technology that's out there to make your life as good as it can be, even in a shit situation. That's what we're talking about here. Maintaining quality of life for you and your tribe, even in bad situations. This, I think, helps with that. Gives you the ability to keep your stuff working, gives you something to do if things start getting crazy and boring. And it really does open up the capabilities of keeping things going, keeping your equipment going, being able to make repairs that you normally wouldn't be able to make life better when things start to get hard. And that's what I got for you today, guys. So remember, do something every day to make yourself or your homestead better, because anything less is unacceptable. You guys are still here? You made it all the way to the end? Well, if you made it all the way in, that means I must have done something right. So go down there to the bottom and hit the little like thingy. Right? If you're not subscribed, hit the subscribe thing. Push the bell. Tell it to notify you when we put out some cool stuff. Right? Help us stick it to the government. Help us get this word out there. Help us show everybody what they need to be doing. Because if you made it all the way to the end of this, that means you think like me. If you think like me, that means you're getting ready like me. And we scare them. And don't be scared of that. Embrace it. Hit the shit at the bottom.